Now it's time for a quiz. What we see here are time-lapse pictures of the same microfluidic channel. Yeah, but just at different moments in time. What has happened here, this is a picture taken in fluorescence, so basically the liquid was quite dark. And I have injected a small plug here, the fluorescent plug here, that's very small, at 0 milliseconds. And as time goes, I have a pumping mechanism that pumps liquid from the left to the right. I see that this plug starts moving in the channel. It's dragged along by the pumping mechanism here. Yeah? And what I see here on the right side is exactly the same kind of starting conditions, so the same channel where I inject the plug. But now also I put a different type of pump here that also generates a flow. And here I see how the plug starts moving also from the left to the right, but now I see that the shape of the plug starts changing. And now the question is, what type of pumping mechanism could have been used to generate these specific flow profiles that I get? Can this be generated by a capillary pump? Can this be generated by a pneumatic pressure difference? Or can it be generated by electroosmotic flow, this kind of pumping? And I want you, for these two different flow profiles, to see which kind of pumping mechanism you think can generate this type of flow. So the answer here is that, of course, what we see here is a flat flow profile, you see? The flow velocity at any point in the channel is the same. Therefore, all points go with the same velocity, no matter where they are placed within the channel. And here we can see that it is not true. So after a certain time, you see that the molecules that were in the middle, the fluorescent molecules here, they have traveled a further distance than the ones that were at the wall. They're almost still at the same position. Yeah? So this is what we see, what we call here, and you can also see this is a parabolic flow profile. And do you remember where you have seen parabolic flow profile? Yes, we have seen that when we calculated the Hagen-Poiseuille equation out of the Navier-Stokes, where we found our flow profile, we saw it's parabolic. And we saw for electroosmotic flow, and that was pressure-driven flow, that was under pressure difference. And here we see this flow, the flat profile we have seen. This is typical for, of course, for electroosmotic pumping, as I have just explained. So we know that this can be generated by a pneumatic pressure difference, and this is generated by an electroosmotic pump, and not vice versa. So what about capillary pumps? Well, what will a capillary pump do? A capillary pump, basically, there you have a pressure drop at the leading edge, and that is just determined by the curvature of the leading front. And so a capillary pump is actually a pneumatic pump, because you have a pressure difference due to the curvature here and just atmospheric pressure here. But the flow profile sees this just as a pressure difference and acts as a pneumatic pressure difference. So a capillary pump will give also a parabolic flow profile.